All right. It's 1:30, so I think we're gonna jump in. Good afternoon, everyone. I hope you're enjoying the conference so far, and I appreciate you all being here. Welcome to this session. The session is called The Future of Open Science Policy, Security of Open Science Software and Data. My name is Jordan Dworkin. I'm based at the Federation of American Scientists, and I'm very excited to be moderating this important conversation with some incredibly sharp thinkers on this topic. So as we've seen over the past couple of years and at this conference, open tools and software and data are increasingly becoming bedrocks of scientific progress and open science. But this key infrastructure often faces difficult balancing acts between maintaining openness, pursuing stable and sustainable funding, and safeguarding against security threats and privacy concerns. So the Year of Open Science in the United States really highlighted the crucial role that government actors can play in supporting open and secure scientific infrastructure. And building on that momentum, my organization, the Federation of American Scientists, in partnership with the Center for Open Science and the Wilson Center, launched an open science policy accelerator to help advance ambitious new policy ideas. I'll put the link to that in the chat. But today we have the privilege of hearing from a few participants in that accelerator who are specifically going to be discussing policy levers and background motivation for strengthening the technological foundations of open science. Their recommendations underscore the need for mapping and supporting key infrastructures, for creating mechanisms for rapid response to security issues, and for establishing robust standards and guidelines for protecting sensitive information. Following their presentations, we will have time for a short kind of moderated discussion and Q&A. So please, as the presenters go along with their talks, feel free to add any questions you have to the chat, and presenters can answer them in the chat, or we can save them for the conversation pending time. I'll also ask at this point that attendees double check that your microphones are muted, just to limit any accidental interruptions. And without further ado, I think we can dive in. I'll introduce the speakers as we go along. And first up, we have Johanna Cahoon. Johanna is a postdoctoral researcher at the Callert School of Computing at the University of Utah. Her work focuses on how research practices change in relationship to scholarly technologies, with a particular focus on the open science movement and scientific software. Thank you for being here, Johanna, and please take it away.
My pleasure. Let me share my slides. Looks good?
Looks good.
Great, thank you. So thanks, Jordan. Like Jordan said, I'm Hannah Cahoon. I'm a postdoc in the Callert School of Computing at the University of Utah, where I study the evolving relationships between research infrastructure and scholarly practices. I started this work as a student of James Howison, who you'll actually be hearing from next, and I'm going to draw on some of the data from a project with him, from my own research, and from some other authors' work to make a point. And that point is that open science infrastructure, like platforms for sharing and web apps for analysis, these are vulnerable to some pernicious threats that have no simple or from-the-box solutions. And the people who build this technology need funding to quickly address these threats. And that's why, as part of the Year of Open Science's policy sprint, I propose that federal science funders should provide grant supplements to funded open science infrastructure projects that recognize emergent security problems and need to fix them. I'm going to touch on a few points to justify this proposal. First, Dr. Howison and I interviewed the principal investigators and contributors to 29 different open source software projects that were funded by the National Science Foundation. And in doing that work, we heard how not all PIs on software projects are security experts. In fact, in the interviews, person after person was telling us how students do much of software development. One PI told us so after saying that they actually couldn't talk about their code themselves because they weren't personally familiar with it. And even faculty who do write code are not necessarily security experts. One participant told us how they learned about a fundamental software development practice, unit testing, during their grant work, kind of bashfully admitting that the software developers they knew from industry were laughing at them for not having unit tests. And they did say that they quickly adopted the practice once they were familiar with it. I don't really expect that PI who recently learned about unit testing to have spotted potential security issues early in their tools development. And I'm also kind of doubtful that PIs like 22A here need to be cybersecurity experts anyway. They are already geoscientists or biologists or physicists and the like. Moving on to the next point, say you have the expertise to know how to test your code for vulnerabilities and you perform updates to keep things secure. That kind of work can still be difficult to prioritize. PIs consistently report that maintenance work is difficult to get funding for, and novel features seem to be preferred by funders. James and I saw this in our study. Other authors have reported the same thing, and I saw it in my dissertation work too. One of the 13 OSF employees I interviewed told me that even though their platform for open science was getting inundated with spam content, they didn't expect to earn grants to remove that spam. Instead, they thought that a funder would say, ugh, that sounds like the most boring thing we can spend our money on. And a natural consequence of having low resources for a task is to prioritize other things that are well supported. But of course, if it's security that's being deprioritized, then that's a risk moving forward. And open science infrastructure is vulnerable to security threats. These could be risks to individuals. For instance, social engineering is used to wrestle money from authors who really just want to raise their publication account. Or risks could be more widespread. Platforms for open science like Zenodo and OSF have to remove spam that spreads illegal content and dubious misinformation. And open testbeds have to defend against things like SSH attacks that allow illegal crypto mining. Because these are tools that are built by people who value inclusivity, universalism, transparency, and openness, open science infrastructure often has a low barrier to entry. There might be no cost, and a fabricated name and email can be all you need to sign up and start using or abusing publicly funded research software. And finally, not all threats can be addressed through relatively straightforward tasks like blocking IP addresses or getting the latest version of a software package. I've mentioned spam a couple of times now, and that's because I think it really aptly demonstrates the real insidiousness of some of these security threats. In my dissertation work, I studied how the OSF is built and used, and I got to witness the real depth of thought that it took for these developers to strategically mitigate the spam that was creeping onto the platform. And it's creeping along with legitimate content, preprints, and data sets. And so the team's really concerned that they might falsely accuse a real user of being a spammer. And they also don't want to arbitrate what counts as legitimate research or not. And this is difficult because not all spam was advertisements for beauty products or live streams like what you see here. Some spam can be disinformation, which is a true security threat. And so 2 years before ChatGPT took off, the developers for OSF had already seen AI-generated content. And here in an interview with me, my participant D3 posed this as a possibility, and then D9 confirmed it already existed on OSF, and this is in 2021. Spam of all types need removing, but some kinds are more difficult to recognize than others and involve a lot more judgment. And how much say do we really want a tech team to have over scholarly norms and what content we can share? Setting boundaries around who can participate in open science might seem necessary to stop infrastructure abuse, but it's also somewhat antithetical to the open science movement's values. And so there's no easy answer here because it's not an easy security problem to solve. If our open science infrastructure is compromised, then the validity of scholarly literature, the reputation of the open science movement, and the investment we've made in it are also compromised. So let's forget what seems boring and what seems exciting. Let's prioritize security and the future of open science. Federal funding agencies should provide supplemental funding to ongoing open science infrastructure projects so they can take quick action and address newly identified security threats. Rather than expecting teams to go through a full grant proposal, this approach allows for a quick turnaround. Projects that have ongoing grants can solicit these additional funding supplements for security work. And by providing resources to prioritize this work, teams can really dig in and think critically about how their security solutions interact with open science values. Thanks for your attention, your commitment to open science. I'm happy to answer any questions you might have during the Q&A session or over email or chat. Thanks.
Thank you so much, Anna. That was fantastic. And yes, please remember to add any questions to the Q&A or write them down so you remember them when we open the floor. Next up, we have James Howson. So James is an associate professor in the information school at the University of Texas at Austin, where he studied open collaboration, particularly in software development. Recently, James has contributed to the development of citeas.org, a system to improve incentives for high-quality software work in science by mapping software to its requested citation. James will be discussing ideas developed in partnership with Karthik Ram. Karthik is a research scientist at UC Berkeley and the co-founder of the rOpenSci project and a founder and editor of the Journal of Open Source Software. But Karthik is unable to be with us today in anything more than spirit. So I will hand it over to James, and thank you very much for your attention.
All right, thanks so much, Jordan, and really, really excited to be here. So we are talking about requiring SBOMs for federally funded research. So here we go. So software matters for science. I think that's pretty well understood in this community. Almost every scientific workflow, these days involves a ton of software. It's crucial for accuracy and for investigation and all sorts of other things. But unfortunately, we don't actually know who is using what pieces of software in each publication. On the right there, you can see some work I did with a doctoral student, Julia Ballard, quite a few years ago now, which shows the sorts of informal efforts people make to mention software in publications. Some citations, but a lot of just random names. And of course, a lot of packages are never mentioned at all because they exist in this kind of deep layer of dependencies, which are absolutely crucial to getting the work done, but are really low in visibility. So if we could improve our insight into software infrastructures, there's lots of things that we could do. So number one, that's pretty key, is that we could improve incentives for the needed software work in science. And I'm sure many people are familiar with this great XKCD comic on the right here, just showing the way all modern infrastructure depends on a small project that somebody in Nebraska has been maintaining for an awfully long time, right? So in our work in science, we've seen lots of in our work on scientific software, some of which was with Hannah. We've seen lots of examples of this where people have worked really hard on components which are getting a lot of use, but they're unable to show, to make clear the relevance and use within the reputation systems of academia. We also think that better understanding of what software was being associated and being used in research for a particular paper would really help researchers with software discovery. And since software really are one of the key ways that people learn about software methods, they'll also help software people to discover new methods and communities of researchers who can really help them advance their work. Better infrastructural insight would also help software projects coordinate with nearby tools. So this one kind of reflects on the fact that, or comes from the fact that when academics and scientific workflows use software, the technical dependencies are important, but the data flow dependencies are also important. But if, as a software package developer, it's often really hard to see that unless you can know who is out there at the forefront of science using your work in research projects. And at that point, you can reach out to nearby tools and coordinate better. And of course, if we had a stronger idea of who was using which pieces of software in publications, then we'd be better able to inform funding decisions for software. And so this could involve everything from funding new pieces of software to funding ongoing maintenance costs in projects, to funding security for widely used projects, to funding things like coordinating workshops for tools that are increasingly used together. So there is a lot of important work that's happening here. And we'll just spend a little minute saying, what are the advantages and the limitations of some of these approaches? I'm sure some of you are thinking, no, we just need to cite all the software. And I'm really, sympathetic to that idea, and have been enthusiastic about it for years. And there's been lots of important efforts, including, work at the Research Data Alliance, at Force 11 conference, to refine how we should mention software, right? Better syntax and targets. But it's always an issue as to what pieces of software rise to the level of contribution that needs citation. And this is a quote here from some participants from a report we did for the Australian Research Data Commons, and they cite everything about the field, from 1920 or whatever. And then when it comes to we write the methods section, we cite every package we use, and that adds quite a lot of citations. Our colleagues get quiet. They're saying, so we have to cut down on the citations. We don't think these are as important, or can we move them to a supplementary material? So it's always a battle for available space in citations. Other work, including some work that Karthik and I have been involved in, and Hannah as well, have tried to reach into publications and extract the things that ought to have been cited from mentions. But those things are very tricky, right? Because it's always limited by what people actually mentions. And it's hard then to actually connect the names of software packages to those packages and their own dependencies. And I am for sure certain that many of you are sitting there and saying, hey, if you just make the whole code stack open, then we don't have this problem. And so full open science definitely solves this problem. But we are unfortunately a long way from that. Currently, it's an uncommon practice. There are questionable incentives. I said questionable motivations here in the slide, but there's certainly questionable incentives for publishing those. There's real concern from our participations about long-term maintenance expectations when all of the code is released. So these things are challenging. So an SBOM is a software bill of materials. And this is not something that we're imagining. This is something that exists and is frequently used. So it is essentially a list of all of the packages connected into the dependency stacks. So when a package is there, we know whether it came from Ruby, from Rust, which of these communities, and therefore the packages that it depends on. And these existing SBOM tools are used for security, and that's because they can help you know what dependencies to monitor and therefore update. And in fact, a US presidential order already requires SBOMs to accompany any software supplied to the US government. And there are a ton of robust tools that enable the creation of these SBOM files. So if we were able to have each paper have an associated SBOM, then we would avoid that competition for limited citation space. We'd get more accurate and complete understanding of the software that's involved without requiring that all of the software behind the piece of research is made fully available. So that leads us to our policy proposal, which is that all agencies that fund research should require that resulting publications include an SBOM listing the software used in the research. On the way to this, probably some feasibility studies would be important. But eventually we'd have an additional file in that publication package, which would enable all of the stakeholders to have better understanding of our software infrastructure. Thank you.
Thank you so much, James. And be sure to drop any questions for James in the Q&A, and we can pick them up in a little bit. For now, I'm going to turn it over to Alyssa Columbus. Alyssa is a biostatistics PhD candidate and Vivian Thomas Scholar at the Johns Hopkins Bloomberg School of Public Health, and has worked as an information security analyst, a data scientist, and a machine learning researcher, and will be talking to us today about data privacy. Take it away, Alyssa.
Thank you, Jordan. All right, well, my computer got a little too eager there. Okay, so hi everyone, my name is Alyssa Columbus, and thank you, Jordan, for your kind introduction. I'm honored to be invited to speak here today, and I'm excited to talk to you about my policy recommendations regarding how to advance open science through robust data privacy measures. So I'd like to start off my presentation with a quote from Dr. Alondra Nelson, the former acting director of the White House Office of Science and Technology Policy. "Openness and security are not contradictory. They are complementary and mutually enforcing. In other words, when data and evidence are made public and open, while preserving people's privacy, it helps others verify that our conclusions are accurate and honest while safeguarding people's well-being. As a biostatistician and data scientist with professional experience in information security and privacy, this kind of philosophy has guided my career so far and influenced much of my work, including this policy memo and set of recommendations. And in this era of rapidly accelerating advancements in data collection and analysis, including AI, realizing the full potential of open science hinges on this delicate balance and duality between data accessibility and privacy. So this begs the question, what has already been done? Federal agencies' open data initiatives are a milestone in the move towards open science. From the Obama administration's Open Government Initiative, kickstarted in 2013, to Dr. Nelson's 2022 policy memo on ensuring free, immediate, and equitable access to federally funded research, to the 2023 Year of Open Science, which came about as a result of Dr. Nelson's memo. We have the potential to foster greater collaboration, transparency, and innovation in the U.S. scientific ecosystem and lead to a new era of discovery. On the other edge of this double-edged sword, the U.S. government has shown a strong commitment to addressing data privacy challenges in many scientific and technological contexts. This commitment has been underpinned by laws such as the Health Insurance Portability and Accountability Act, or HIPAA, and regulations for human subjects research, the main one of which is the Code of Federal Regulations, Title 45, Part 46. Also, the White House Office of Science and Technology Policy has spearheaded the national strategy to advance privacy-preserving data sharing and analytics, aiming to further the development of these technologies to maximize their benefits equitably, promote trust, and mitigate risks. In addition, the National Institutes of Health, or NIH, operate an internal privacy program responsible for protecting sensitive and identifiable information within NIH work. And the National Science Foundation, or NSF, complements these efforts with a multidisciplinary approach through programs like the Secure and Trustworthy Cyberspace Program, which aims to develop new ways to design, build, and operate cyber systems, protect existing infrastructure, and motivate and educate individuals about cybersecurity. So clearly, much has been done to address both sides of the security transparency coin. But given the unique challenges within the context of open science and the wide reach of open data initiatives across the scientific ecosystem, there remains a need for further development of clear policies and frameworks that protect privacy while also facilitating the efficient sharing of scientific data. And coordinated efforts across the federal government could ensure these policies are adaptable, comprehensive, and aligned with the rapidly evolving landscape of scientific research and data technologies. Which leads me to my policy recommendations. Overall, the scope of my policy recommendations is encapsulated in this main goal highlighted towards the top of the slide, with the 4 main supporting steps outlined below. The White House and federal science agencies should build on existing data privacy efforts by collaborating to develop and implement clear standards for research data privacy across the data management and sharing lifecycle. They should do this by 1, clarifying standards and best practices for research data privacy. 2, ensuring best practices are used in federally funded research. 3, catalyzing continued improvements in data privacy technologies. And 4, facilitating interagency coordination. To clarify standards and best practices for research data privacy, NIST should build on its existing research data framework to develop a new framework that is specific to research data privacy and addresses the unique needs of open science communities and practices. This would provide researchers with a clear roadmap for implementing privacy-preserving data sharing in their work. This framework should also incorporate the principles of privacy by design, ensuring that privacy is an integral part of the research lifecycle rather than an afterthought, and be regularly updated to stay current with the changes in state, federal, and international privacy laws, as well as new privacy-preserving methodologies. This will ensure that it remains relevant and effective in the rapidly evolving data privacy landscape. To ensure best practices are used in federally funded research, funding agencies like the NIH and NSF should work with NIST to develop and implement training for data management and sharing plan applicants and reviewers. This training would equip both parties with knowledge of best practices and privacy-preserving data sharing in open science, thereby ensuring that data privacy measures are effectively integrated into research workflows. Agencies should additionally establish programs to foster privacy education, as recommended in the White House Office of Science and Technology Policy National Strategy on Privacy Preserving Data Sharing and Analytics. And training on open data privacy could additionally be incorporated into agencies' existing responsible conduct of research requirements. To catalyze continued improvements in data privacy technologies, science funding agencies should increase funding for domain-specific, for example, health or software-specific, research and development of privacy-preserving methods for research data sharing. And such initiatives would spur innovation in fields like cryptography or secure computation, leading to the development of new technologies that can broaden the scope of open and secure data sharing. And to further stimulate innovation, these agencies could also host privacy or security innovation competitions, like some other agencies have hosted machine learning competitions in the past, which would encourage researchers and developers to create and implement cutting-edge solutions. And finally, to facilitate interagency coordination, the White House Office of Science and Technology Policy should launch a National Science and Technology Council subcommittee on research data privacy within the Committee on Science. This subcommittee should work closely with the Office of Management and Budget, leveraging its expertise in overseeing federal information resources and implementing data management policies. This collaboration would ensure a coordinated and consistent approach to addressing data privacy issues in open science across different federal agencies. Thank you for listening to my talk. And I'd also like to extend a thank you to the organizers of this event, particularly Jordan Dorkin, for putting on this wonderful conference and inviting me to speak. And if you have any questions, I'd be delighted to answer them during the moderated Q&A session later, or if you want to discuss anything later, feel free to contact me through my website, which is just my first name and my last name, alyssacolumbus.com. Also, more information on everything I talked about can be found in my policy memo, which is cited in full on this slide, and I believe Jordan also put a link to all of our policy memos in the chat. Thank you.
Amazing. Thank you so much, Alyssa. That was fantastic. So last up, we have our final presentation before we jump into the Q&A. Our final presentation is by Saeed Chowdhury. Saeed is the Associate Dean for Digital Infrastructure and the Director of the Open Source Programs Office at Carnegie Mellon University. He's a board member of the Open Source Initiative and a founding member of the Community of University and Research Institution Open Source Program Offices. And Saeed is going to be talking about public-private funding for open source infrastructure. Take it away, Saeed.
Thank you, Jordan. Real pleasure to be here, and thanks to you and the organizers of the conference. I just dropped a link in the chat to my policy recommendation, and I'm actually going to begin by reading the policy recommendation and then justifying it, hopefully, or at least trying to persuade you to believe in the idea. The recommendation is that the U.S. should establish a digital technology fund to provide direct and indirect support to OSS projects and communities that are essential for the public interest, national security, and global competitiveness. The Digital Technology Fund would be funded by a coalition of federal, private, academic, and philanthropic stakeholders and would be administered by an independent nonprofit organization. So Johanna made the very good point that open science infrastructure is vulnerable and there are security issues. That is true of all open infrastructure, not just scientific. And open source software is ubiquitous. It is everywhere at this point. Just to give you a couple of reference points, there is the Open Source Security and Risk Analysis report that comes out every year. And in the current version, they noted that 96% of all total code bases contained open source, and that 77% of all code in those code bases originated from open source. And in terms of economic impact, a researcher at Harvard named Frank Nagel just published a paper where he said that the value of supply side widely used open source software, production of open source software, is $4.15 billion, and that it would require 3 to 4 times that amount if we worked with proprietary software. And even more amazingly, I suppose, on the demand side, in terms of what consumers have benefited, it's $8.8 trillion, so with a T, not a B. And he makes the really interesting point that 96% of this demand side value is created by only 5% of open source developers. So that diagram that James shared of that person in Nebraska, these maintainers are really critical in terms of both the security and the sustainability of open source software. And in many ways, for the first time, we have now major infrastructure efforts dependent on single individuals. And that is a very profound change. And it's very empowering, and it's very energizing in many ways, but it does raise some of these concerns that we've been discussing. So there is a relationship between security and sustainability. So I think anything we can do to bolster security in some ways helps with sustainability as well. This is a multi-dimensional, multi-tier problem, and it will take a multifaceted approach to address that. The director of the Cybersecurity and Infrastructure Security Agency, Jen Easterly, has made this point in several presentations, including one she gave at CMU. So I think this digital technology fund would be part of a larger overall strategy. It is inspired by, if you will, the German Sovereign Tech Fund, which is something that is similar. It has slightly different kinds of scope and mission, if you will, but quite frankly, European Union has a different perception of the big tech companies than we might in the US. But beyond that, there are similarities in terms of better understanding of the risks, who are the stakeholders, what are the role of maintainers, the kind of dependency understanding that James talked about would be critical in trying to think about who exactly do we fund. So the Sovereign Tech Fund was established to better identify those types of individuals. And it's worth noting that in the US, there are attempts to support maintainers and the people that do this work, but it's really not strategic. It's not intentional. It's very ad hoc. It's somewhat idiosyncratic. It's somewhat organic. There are large companies that are funding key components of our critical infrastructure. But again, they're probably doing it for their self-interest. They don't necessarily know what other companies are doing. They don't know what individuals might be doing, and so on. So this digital technology fund would allow us to take a more cohesive, systematic approach to identifying the risks, to funding the risks, and probably most importantly, develop a partnership or a triad between academia, government, and industry. And when I think about the creation of the internet or the web, it really was that triad that came together and worked intentionally together to build out this infrastructure. We haven't had that so much with open source. And I think one of the ironies for me is that open source really began in universities, but for some reason we maybe lost our way, if I want to, I don't know how else to say it. And I do appreciate the work that the private sector has done in that interim period, but we need to rebalance the sort of role between universities, industry, and the government. And I think there's an openness to making that happen. The Office of the National Cyber Director issued a request for information last year around open source security and sustainability. They received many responses. I was at a workshop about a week and a half ago organized by CISA, where they said they are summarizing those responses and will share a report that identifies the findings from those responses. That is a great springboard from which we can say this is an initial landscape analysis. Now we can go further. We have a more directed way of moving toward doing this in a systematic and strategic way. So ultimately, one might be ambitious enough to even think there could be a congressional authorization to create the fund, and then to have the agencies that are now charged to think about this, like CISA or the Office of the National Cyber Director, and put together a group that would administer this, at least initially, and be more open and transparent about how we're funding this and how we want to work together in order to fund this. So with that, I'll turn it over to the panel and to Jordan for some discussion and hopefully some questions from all of you as well. Thank you.
So thank you so much, Sid. So that gives us about 15 minutes to discuss and answer any questions. I see one so far in the Q&A. Feel free to add more as we talk, and you can also raise your hand using the reactions button. And if you want to kind of come off mute and ask your question live, I'll happily call on you. But I wanted to kick us off with kind of an open-ended question for the panel. A lot of these issues, as Hannah very compellingly illustrated, are not necessarily anyone's top priority for addressing. There's a lot of kind of moving the ball around and finger pointing and wanting to play a certain role in the ecosystem, but thinking that some other institutional body or sector can play a different role. So I think a lot of these policy ideas and a lot of the movement in this space requires kind of coalition building between kind of researchers and universities and philanthropy and government to kind of make progress towards policies and programs that are not necessarily fully aligned with any individual actor's incentives. And so I wanted to kind of open up to the panel and even to anyone in the audience to kind of describe how you think about that kind of coalition building towards activities that may not be individually aligned with a single sector or actor. And I'm happy to let anyone kick it off if you have thoughts.
I mean, I'll jump in. Echoing something I said, I think what we've encountered is the initial instinct or reaction was, oh, I can free ride, right? And open source is this wonderful thing, and I will just benefit from downstream, uses of it. And what's happened, particularly in the private sector, is the realization very quickly that is not going to work for the long term. That in order to keep using open source software in a secure and sustainable way, you can't just free ride. You have to participate in actually further upstream activities, identifying who's doing the work, and being intentional about supporting them. But that has not led to a cohesive approach, right? So I think we have the willingness and the sort of eagerness to have these kinds of conversations. We don't necessarily have the frameworks in place. And I think each of the policy recommendations from this panel can help us get to pieces of that. And then, I mean, obviously I would love to see all of them supported and funded, but I think that comprehensive approach could be really helpful.
I'd add just that we're talking about changing not just 5 minutes of someone's day, but the tools that they're using, the technology that supports those tools. It's a complex system with many organizations. And to change that whole system, you do need involvement from everybody. And I think that the open science movement in general kind of recognizes this. There's lots of partnerships between organizations, academics, governments. But I would also add that even our suggestions here are not the only way to approach these problems. My own suggestion of providing additional funding, there's also educational opportunities. So there's lots of different ways that can involve many different actors in throughout this process.
Yeah, one of the most important lessons that I think I learned in my career so far is that information security and privacy is everyone's responsibility. In order for anything to be truly private or secure in an analytical context or in a software context, everyone needs to play a role. And that's also kind of a double-edged sword in some way, and that it's also quite difficult to get everyone on board, or at least everyone aware of what's going on. I feel like this panel is helping somewhat in that area to spread awareness about these sorts of issues, and also to provide potential solutions. But also it's ultimately up to everyone and up to those kinds of change management processes over time that can take on many different forms, as I outlined in my policy memo and as other people on this panel outlined, involving education or additional funding, or even just additional attention, additional, perhaps even volunteer work from people who are willing to take the lead and lead the charge in this area.
Thank you all. Those are very thoughtful answers. I think Kyle has asked a couple questions in the Q&A. One, it looks like James answered directly in the Q&A section. So if folks want to read through his response about proprietary software and how that interacts with any kind of movement towards SBOMs, you can find it there. But another more open-ended question for the panel that Kyle asked was, do you view existing academic publishers as allies or hindrances to the kind of open science and open data coalition building that was discussed here? That's an interesting question. Folks want to dive in?
I mean, I'll jump in and say, from the perspective of, they're very important in the publishing tool chain. I mean, obviously, right? And so getting them on board with, efforts like this, because somebody would, let's say this requirement would have to be in place, somebody would have to check that it was happening. And so publishers would play that role. Generally, in my conversation with publishers, they are interested in things that improve the quality of the articles that they're publishing, and they're interested in ways that the totality of the articles can be turned into alternative forms of knowledge right now. So whether that's publishers like the AGU, who have like more of a scientific mission, or even for-profit publishers looking to build benefits out of larger data sets drawn from their papers, either one of those could work towards the sorts of things I'm talking that we've been talking about. So potential allies. Answer.
One point I'll make is we heard about the public access memos, and if you go back to 2013, there was a Holder memo, and I've had this maybe naive view of the public access memos in some sense are moving from articles to data to software over time in terms of what the emphasis might be. And I think that the relationship with I'll say more broadly, private sector, including for-profit publishers, is different with each of those milestone points, if you will. And when it comes to open source software, the large STM publishers and even the scholarly societies or scientific societies don't necessarily have much of a role yet. There are things like JOSS, right, the Journal of Open Source Software, that's taken a real leadership role in that, but I don't think that was because a publisher prompted it, and that the relationship more broadly with the private sector is an opportunity in this case. There are many large tech companies, too small companies, working with open source that are eager to solve this problem together. And eager to work with universities. So you'd mentioned this new network called Curious, Community of University and Research Institution OSPOs. We're coming together to potentially provide sort of like, an organizational API for people to work with universities to address this problem. So I think there are more opportunities when you think about software in particular.
Also, I completely understand the like natural inclination to think of groups or organizations as maybe an ally or a hindrance in this situation, but like realistically, everybody is both. And I really would never want to label anyone as a hindrance. Perhaps we all engage with challenges, but kind of by the same token, you could think of individual researchers as either an ally or a hindrance to open science. And that's not really a productive way of thinking about it. Like a more productive approach would be to say, like, what are the opportunities, and maybe what opportunities don't exist yet, and how can I bring them about? But treating any group with a broad brush can limit the action we can take later. And I think a lot of the change that we need to see related to open science is really about building bridges. And so being careful about the terminology we use and how we approach one another when asking for change can be just as critical. Like the approach can be just as critical as what we're asking people to do.
I agree with Hannah's point that we shouldn't view any parties in terms of a binary support or not support, enable, not enable, but we should rather look at things that on like a gradient scale of how much do they really support this kind of thing or not, like on that sort of a continuous scale instead of a more discrete one. And I know that at least in the statistical community, there have been movements toward including more open data and more open software, and even like mandating that in some journals now. So it's definitely gaining steam, at least within my scientific community, especially due to President Biden's recent executive order about mandating opening up research that has been federally funded. So I'm optimistic overall.
So another questions from the group. I'll piggyback off of that because I think this kind of conversation around buy-in from variously aligned parties is really relevant here when we talk about kind of expanding the scope of kind of open science activities in the community to software, to manifests, to data privacy knowledge and implementation. I think a few of the proposals themselves get around this issue by kind of talking about resourcing and funding and providing capacity for doing some of these things. But in general, I think a lot of these require asking researchers to think of their own role as being one that kind of takes on another more computational, more technical lens than they might have previously conceptualized it. And I think a few of the folks on this panel have directly had these conversations with researchers and thought through what this looks like. And I would love to hear kind of the group's perspective on that communication strategy, building that buy-in, making some of these activities feel like kind of a natural and desirable extension of current workflows rather than kind of something that is a burden and unwanted.
I mean, personally, I just imagine research teams and the related roles expanding. I don't necessarily think that the geoscientist or biologist needs to be the security expert, but they need to know how to find someone who can point them to resources or point them to best practices or introduce them to a potential collaborator. Yeah, I imagine research teams expanding their roles, more project managers, more close relationships with librarians, these different competencies that we're saying are necessary for secure and successful open science. I spent 6 years getting my PhD. Like, how much longer should I spend? These are team efforts, and we all have our role to play. But I imagine a lot more interdisciplinary work and expanded positions available in research teams.
I think it really makes me think of Alyssa's work more here, right? So one of the things that's really terrifying if you ever release a data set is privacy concerns, right? People are very, very worried about, if they release a data set, will people use it for privacy invading purposes? But, what I really admire in Alyssa's work is she's pointing out that, with more research and promulgating some of the techniques that exist, we can actually really tackle that problem and take that level of concern, from the researcher's shoulders. They'll know that they're using validated and appropriate, best case techniques. And I think that's really important. So that should help the researcher rather than be an additional burden.
Thanks both. We've got 2 minutes left. If anyone wants to sneak in a last minute question, feel free to raise your hand or drop something in the Q&A. Also open the floor for any of the panelists. If you have a question for each other or for the group or just another idea to raise, feel free to do so. And if not, we can give you all back 1 extra minute of your afternoon. And please join me again in thanking our panelists, Hannah, James, Saeed, and Alyssa. Thank you so much for your presentations. This was a fantastic conversation.